Welcome to our deep dive. We're going to be looking at implicit language models today.
Okay.
Specifically, we've got this research paper, Implicit Language Models are RNNs, balancing parallelization and expressivity.
Right.
We've also got some supplementary material like study guides and briefing documents. But what we're trying to do today is, oh, hey there, how can we help?
Hey there. Can we can we explain the key points of the work from the high-level intuition first?
Hey there, that's a great idea.
Yeah, let's totally do that.
Okay, so at a high level, you can think of it like this. Traditional language models, like transformers, are really good at processing information in parallel, right?
Okay, like they can scan a whole page of text really quickly, right?
Exactly. But sometimes they miss those subtle, nuanced connections between words.
Yeah, like they don't always grasp the deeper meaning, right?
Right, and so that's where these implicit models come in.
Okay, so how do they do it?
They use this concept of self-iteration, which is like they refine their understanding of the text step by step, almost like a human would.
So it's like they're taking the time to really dig into the details, not just skimming it over.
Exactly, and they only do that when they need to, which makes them really efficient.
Okay, so it's like they're blending the speed of parallel processing with the nuance of human-like understanding.
That's a great way to summarize it.
Awesome. So with that in mind, I think we can now dive into the details. Is that cool with you?
I think so, yeah.
Okay, so we were saying that what we're trying to do today is understand how these implicit language models are really kind of pushing the boundaries of what's possible with AI.
Yeah, that's really the goal here.
And one of the things that's really interesting about these models is how they kind of blend two seemingly opposite approaches to processing information.
Absolutely. So, like, the challenge in language modeling has always been this, like, trade-off, right, between parallelization and expressiveness.
Okay.
And on one hand, you want speed, you want efficiency, you want to be able to process information really, really quickly.
Like just scanning a page, right?
Yeah, exactly. Like, just get it all in at once.
Yeah.
But on the other hand, you need the model to understand complex relationships and nuances, right? Like you
Right.
want it to be able to like savor the flavors of a gourmet meal.
Okay, yeah. So it's like the difference between speed reading and deep reading.
Exactly. And so this is really where traditional models like transformers and state space models, SSMs,
Right.
they hit their limits.
Okay.
They're really good at parallelization. They can process information rapidly, but they struggle with tasks that require them to understand complex, interconnected information over time.
Interesting. So is that where these implicit language models, is that where they come in?
That's exactly where they come in.
Okay.
So they use this really interesting concept called self-iteration.
Okay.
And it's almost like they shift gears. They start to behave like a recurrent neural network or an RNN when the situation demands it.
Okay.
So imagine like if you're trying to solve a complex equation,
Yeah.
instead of cracking it directly, you make an educated guess and then you refine that guess over and over again, until you hit a stable point.
Uh-huh.
And that's sort of the idea behind what we call fixed point iteration in these models.
So they're not just processing everything at once, they're kind of going through it, refining their understanding.
Exactly. Yeah, they're taking that extra time to really figure things out.
Okay. But wouldn't that make them like incredibly slow?
So that's where the magic of phantom gradients comes in.
Okay.
Instead of recording every single step of the self-iteration process, which would be computationally very expensive, they use this shortcut to calculate the gradients only at that stable, that fixed point.
Uh-huh.
And so this allows these models to be incredibly efficient, even when they're dealing with massive amounts of data.
So it sounds like they're finding a shortcut without sacrificing accuracy, which is pretty impressive. But I mean, do these models actually deliver, like, how do they perform in real world tests?
Yeah, so the researchers put them through some pretty rigorous challenges. One of them is something called the S5 word problem, which is specifically designed to test a model's ability to track complex sequences of information.
Okay.
You can almost think of it as an AI obstacle course for language models.
Oh, okay. Interesting.
And the results were really impressive. The implicit models aced it. They even outperformed traditional models on a whole bunch of other benchmarks that are designed to assess reasoning and state tracking abilities.
So it's not just that they're fast, it's that they're actually learning and adapting.
Yeah, that's right. It's about being smart and efficient, not just fast.
You mentioned data sets used for training and testing.
Yeah.
Can you tell me a little bit more about those?
Yeah, absolutely. So they used a massive data set called dpile, which contains a staggering 207 billion tokens. They used that to train these models. And for testing, they used a data set called CACBB. It's designed to evaluate a model's ability to reason about events in a story.
Oh, so it's kind of like a test of narrative comprehension for AI.
Yeah, that's a great way to put it.
Wow, the scale of these experiments is mind-boggling. What does all of this mean for the future of AI? I mean, what possibilities do these implicit models unlock?
I mean, the potential is vast, right? Like, imagine AI systems that can not only understand the literal meaning of words, but also grasp the deeper meaning and context behind them.
Yeah.
Systems that can actually reason about complex situations, learn from their experiences, and maybe even help us solve some of the world's most challenging problems.
It sounds like we're moving beyond simple language processing and entering a new era of AI that can really understand and interact with the world in a much deeper way.
Absolutely. I think we're just scratching the surface of what's possible.
Wow.
And this is just the beginning, right? There's still so much to explore, especially as new hardware emerges that can further accelerate the development and deployment of these powerful models.
Yeah, I mean, it sounds like we're on the cusp of some really, really amazing breakthroughs.
I think so. Yeah, it's a very exciting time to be working in this field.
Absolutely.
So we were talking about the potential of these implicit language models, but let's dig into the research a bit.
Okay.
You know how we talked about that S5 word problem, like the AI obstacle course?
Right.
They used it as a proving ground,
Uh-huh.
not just to see if these models could solve it, but
Right.
to understand how they were arriving at the solution.
Because it's not enough to just get the right answer, right? We want to know if they're actually learning or are they just, brute forcing their way through it.
Exactly.
Yeah.
Okay. What they found is that these models actually adapt their approach based on the complexity of the problem.
Okay.
So like those non-solvable transitions that require that state tracking.
Yeah, those parts of the problem, they seem to be the real sticking points for a lot of models.
Right, and that's where the researchers found that the implicit models only engage their RNN superpower when they encounter those challenging sections.
So they're not just like applying it all the time.
Nope, it's like they're conserving their energy
Interesting.
and only using it when they absolutely have to.
So it's almost strategic, like a chess player who saves their most powerful moves for like the really critical moments of the game.
That's a great analogy. I mean, it really suggests like a level of sophistication we haven't seen before.
Right.
You know, they're not just blindly applying the same technique, they're learning to strategize and adapt.
So how do you train a model to be this adaptable? Like, is there a special technique the researchers had to develop?
Yeah, they actually used a two-stage training process. They call it the bounded phase and the free phase. You can think of it as like gradually increasing the difficulty level,
Okay.
giving the model a chance to learn and adapt at each stage.
So it's like a training montage in a martial arts movie.
Oh, I like that.
They start with basic exercises and then they gradually work their way up to like, the high flying kicks.
Exactly. So during the bounded phase, they limit the number of self-iterations the model can perform.
Uh,
It's kind of like a sprint,
okay.
forcing them to find the most efficient solution within a limited time frame.
So they're really being pushed to like find the most streamlined approach.
Exactly, yeah.
Ah,
Then in the free phase, they remove the limitations and allow the model to really unleash its self-iteration power.
okay.
So now it's a marathon.
Mhm.
They can take their time and really explore the problem more in depth.
That's a really fascinating training regimen. But did it work? I mean, it put these models like it generalized their knowledge to new, unfamiliar situations?
Right, that's the ultimate test, right?
Yeah.
To see if they're truly learning or just memorizing solutions.
Right.
So the researchers evaluated these models on data that they had never seen before,
Okay.
and they wanted to see if they could apply what they had learned to these novel situations.
It's like being, dropped in a foreign country and having to navigate using only your language skills.
Exactly. Yeah.
Okay.
One of the key tests was how well these models performed on sequences of text that were longer than what they had been trained on.
Uh-huh.
Because traditional models, they tend to struggle as the text gets longer, right?
Right, because they kind of lose track of the context.
Exactly. Yeah, like losing the thread of a really complex story.
Yeah.
But the implicit models, they showed remarkable resilience, like their performance remained stable even as the text length increased,
Interesting.
demonstrating this ability to really maintain that coherent understanding over these extended periods.
So they can handle the long game, so to speak.
That's a great way to put it. Yeah, and that's crucial for real-world applications, right?
Right.
Where AI systems are going to be encountering unpredictable situations and need to adapt on the fly.
Right.
So we've talked about the S5 word problem, we've talked about the Cat-Babby data set, these tests of like length generalization.
Uh-huh.
Were there any other like interesting findings, anything that really surprised the researchers? One thing that they found really surprising was the ability of these models to seamlessly switch between two different modes of processing information.
Okay, remind me, what are those two modes?
So you've got the simultaneous mode and you've got the sequential mode.
Okay.
Simultaneous mode is all about speed. It processes information in parallel, like a team tackling different parts of a project all at the same time.
Okay.
It's efficient, but it can sometimes sacrifice accuracy.
Right, because you're not going as deep.
Exactly.
Right, okay.
It's like scanning a book just to get the gist. You might miss some of the details.
Okay.
The sequential mode is more deliberate. It processes information step by step.
Okay.
It might be slower, but it allows for a more nuanced and accurate understanding.
So it's like choosing between a quick scan and a deep read.
That's the perfect analogy.
Okay.
But what's remarkable is that these implicit models can effortlessly switch between these two modes.
So they can do both.
Yeah, depending on what the situation demands.
Wow, so they could be a sprinter and a marathon runner.
Exactly.
Okay.
And this flexibility makes them incredibly adaptable and opens up a whole new world of applications.
This all sounds incredibly promising, but are there limitations to these models? Like, are there challenges that still need to be addressed?
I mean, one of the key challenges right now is just computational power. These models, even with their shortcuts and efficiencies, they're still very resource intensive to train. So you need a lot of computational resources, and that can be a barrier for some.
So access to these tools could be limited?
Yeah, for now at
Well,
least.
yeah.
But there's a lot of research going on to develop new hardware
Right.
that can specifically accelerate these types of models. So,
Oh, yeah.
imagine like custom-built engines that are designed to power these advanced AI systems.
Right, because you need the right tools to really unlock the potential of this technology.
Absolutely.
Yeah, this has been an incredibly insightful look into like the inner workings of implicit language models.
Yeah.
What's next? Where do we go from here? We've really been digging deep into the technical stuff with these implicit language models.
Yeah, it's been a lot of technical detail.
But I think now it's time to kind of like zoom out and think about the bigger picture, right?
Absolutely, yeah.
What are the potential applications? We talked about healthcare and scientific research.
Uh-huh.
Can you maybe elaborate on how implicit models could revolutionize those fields?
Well, in healthcare, imagine a world where AI can analyze a patient's complete medical history,
Okay, yeah.
not just like isolated snapshots, and use that information to assist doctors in making more accurate diagnoses.
That would be huge, especially for like complex cases
Exactly.
where there's lots of, medical history to consider.
Absolutely.
And then in scientific research.
In scientific research, you can think about AI collaborating with scientists,
Okay.
sifting through mountains of data,
Yeah.
identifying hidden patterns and connections that would take humans years to uncover.
So like accelerating breakthroughs in things like climate change or drug discovery.
Precisely. Yeah.
Wow. So it's really like giving researchers a cognitive boost,
Yeah.
empowering them to solve problems that were previously like just intractable.
Exactly. Yeah.
Oh, go for it.
Can we explain the explicit and explicit from the intuition way?
Okay, I think I understand what you're asking.
Yeah, it sounds like you want us to really spell out the intuition.
Right, like make it as explicit as possible.
So instead of thinking about the how they work, let's really dig into the why.
Okay, yeah, so like why are these implicit models even a thing?
Exactly. Let's go back to the core problem.
Which is that trade-off between parallelization and expressivity.
Right. You've got these models like transformers that can process tons of text in at once.
But they can't always grasp complex relationships, right?
Exactly. And then you have models like RNNs that can handle those relationships.
But they're not that great at processing things in parallel.
So implicit models try to get the best of both worlds.
Okay.
They can process information in parallel, but they can also engage this RNN mode.
Right. When they need to dig a little deeper, they use self-iteration.
And that's where the nonlinearity comes from.
Okay.
They aren't just doing a simple linear calculation.
They're feeding the result of one calculation back into itself.
Until they find a stable answer.
So it's like they're refining their understanding step by step.
Exactly. And that is what makes them so powerful.
Okay.
And they only do that when they need to.
Which makes them super efficient.
And that's why this method is so unique.
Hopefully that makes it a bit more clear.
Yeah, hopefully that gets at the core intuition for you.
So with that in mind, where were we?
We were talking about applications of the model.
Oh,
We
right.
mentioned healthcare and scientific research.
And I think we were about to go beyond those fields.
Yes.
Beyond those two fields, I mean, what other areas could be impacted by this technology?
Education could be totally transformed.
Okay.
Personalized learning that's tailored to each student's unique strengths and weaknesses.
Right, right.
Imagine AI tutors
Okay.
that adapt their teaching style in real time, providing individualized support and challenges.
That's fascinating. I mean, that could make learning so much more engaging and effective for everyone.
Absolutely. Yeah.
And we can't forget about the creative industries. I mean,
Right.
a lot of people, they get kind of nervous when they hear about AI assisting writers.
Sure.
But I mean, I see it more as like a tool for expanding creativity, not replacing it.
Exactly. Yeah, it's not about replacing human creativity. It's about augmenting it.
So instead of, fearing AI as this threat,
Right.
we should see it as like a collaborator.
Absolutely. Yeah.
So imagine like AI helping writers overcome writer's block, explore new narrative structures,
Right.
even translate their work seamlessly into multiple languages.
Exactly. Yeah, the possibilities are really endless.
Those are some really compelling possibilities. But I mean, with such powerful technology, there's always concerns about potential downsides, right?
Sure.
What are some of the challenges that we really need to consider as these implicit models become more prevalent?
Well, I think like with any powerful technology, there's a risk of misuse, right? Or
Mhm.
unintended consequences.
Right.
For instance, if these models are trained on biased data,
Yeah.
they could perpetuate or even amplify existing societal inequalities.
Right. So we really need to make sure that the data that we're using to train these models is fair and representative of everyone.
Absolutely, yeah. Fairness and transparency in development, they're critical.
And rigorous testing too, right?
Of course, yeah.
To make sure that these biases aren't creeping in.
Yeah, we need to be very careful about that.
And then there's the potential impact on the workforce, right?
Sure.
I mean, as AI becomes more capable, it's natural to worry about job displacement.
Of course, that's a valid concern, yeah.
But it's something that we need to address head on, right?
I think the key is to focus on collaboration,
Okay.
finding ways for humans and AI to work together.
Right. Augmenting each other's abilities.
Yeah, excellent.
Rather than simply replacing, one with the other.
Yeah, I think that's the key to a successful future with AI.
And maybe the most fundamental question is, what does it mean to be human in a world where AI can perform tasks that we once considered uniquely human?
It's a big question, right?
It is, yeah.
It challenges us to reevaluate our own definitions of intelligence, creativity, even consciousness.
It forces us to confront these like profound philosophical questions that have puzzled thinkers for centuries. I mean, the evolution of AI is not something that we can just ignore, right?
No.
It's happening, and it's shaping our world in ways that we're only beginning to understand.
And I think it's happening much faster than a lot of people realize.
So how do we navigate this uncharted territory responsibly? What steps can we take to ensure that AI is used for good?
Open dialogue is essential.
Okay.
We need collaboration across disciplines, involving ethicists, policymakers, the public,
Right.
to really engage in these thoughtful discussions about the future that we want to create.
Because the future of AI is not predetermined.
No, it's not.
It's a future that we are actively shaping
Yeah.
through our choices and our actions.
It's up to us to decide what kind of future we want.
This deep dive into the world of implicit language models has been really incredible.
It has, yeah.
We've explored their technical marvels,
Uh-huh.
their vast potential,
Yeah.
and the critical questions that they raise about the future of AI.
And hopefully we've inspired some of our listeners to learn more about this field.
Yeah, because this is just the beginning, right?
Oh, absolutely. We're just scratching the surface.
So thank you so much for joining us on this intellectual adventure, and until next time.
Yeah, keep those minds open and those questions coming.